Hey everybody, welcome to class F. We're going to talk about circles. Let me share my screen. So we're going to talk about circles, obviously. Specifically, we're going to talk about the equation of a circle and finding the radius and center of a circle. Let's start off with one other thing, which is, what is a circle? And I'm going to kind of go back for a second and actually think about, what is a line? Well, a line is a collection of points that satisfy an equation, right? Every point on the line y equals 3x plus 1 satisfies the equation y equals 3x plus 1. So for example, right, y equals 3x plus 1 has an infinite set of points that are on it. The point 1 comma 4, the point 2 comma 7, the point -1 comma -2, and the list goes on and on, literally forever. So a line is an infinite collection of points that satisfy this equation here, and they all are in a line. A circle is the same sort of thing. A circle is a set of an infinite set of points, right? There's an infinite number of points that are all the same distance away from a center. So it's the set of all points that are some specific distance, which we call the radius, from the center. That is the whole deal. And yes, when we say the set of all points, we mean an infinite set. We're not going to list all of them, just like we're not going to list the infinite set of points that make up this line, but they are there. So let's look at some examples. Well, some examples and some generalizations. So let's start off with this example. We're going to find the equation of the circle whose center is 1 comma 4. Yeah. And whose radius is 3. I'm actually going to draw it first, and then we'll talk about finding the equation. So center is 1 comma 4, so up 1 over 1 up 4. There's the center, which technically isn't a point on the circle, and the radius is 3. So I'm going to go 3. When I draw a circle, I like to go 3 in each of the 4 directions: up, down, left, right. So I'm going to go 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 left, 1, 2, 3 down. And your drawing doesn't have to be perfect. Just try to make it as good as you can. Mine might be pretty good because I've had a lot of practice, but I'm saying that before I finish doing it, so I'm sure it'll go poorly now that I've said that. It turned out okay. So there's my circle of radius 3. And I want to point out, right, any point on the circle, right? So here's the point 1 comma 4, which is not on the circle. 3 to the right is the point 4 comma 4. 3 up is 1 comma 7. 3 left is -2 comma 4. 3 down is 1 comma 1. You don't have to label these other points. I just like pointing out what they are. But those aren't the only points, right? There's literally, as I've said a few times, an infinite number of points. So like this point over here, the distance there is also 3, right? The distance here is 3. The distance here is 3. All of the distances from any point on the circle to the center is going to be 3. So what we're going to do is we're going to call this point here x comma y. It's representing a general point on the circle. So just like x comma y represents a point on the line, and you can find the equation for the line, x comma y can represent the point in the circle. And so what we're going to say is, okay, well, we know, based on what we've just said, is that the distance between this point and the center has to be 3. Well, great. I know an equation for the distance. So I'm going to say the distance between this point and this point. Well, the distance equation for point to a point is going to be the square root of x minus 1 squared, right? The difference in the x's squared, plus y minus 4 squared, the difference in the y squared. And we know what that distance actually is, right? We have said this circle has a radius of 3. So any point on the actual circle is exactly 3 away from the center. So the distance between this point here, x comma y, and this point here, 1 comma 4, has to be 3. There's nothing else to say about it. Now, what we're going to do is we're going to manipulate this just a little bit. We're going to take this equation here, right? I don't actually need the part that says d equals. I was just using that to write the distance. We're going to take that equation and we're going to square both sides. Why? To make it look nicer. There's really no good actual reason to do this other than it looks better. So if we square both sides, and I'm going to write it out, we're going to have the square root of x minus 1 squared plus y minus 4 squared equal to 3 squared, which is then going to lead to, when you square a square root, they undo each other. So you're just going to get the inside stuff here, which is x minus 1 squared plus y minus 4 squared. On the right-hand side, 3 squared is 3 times 3, which is 9. And that is the final result. This is the equation of the circle of radius 3 that is centered at the point 1 comma 4. I will point out that we don't do anything else with this. There's no more simplification to do. This is what's called the standard form of the equation of a circle. So let's actually write this in there. This is the standard form, or the standard equation of a circle. It's always x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equal to the radius squared. You don't want to write that as 3 squared. You want to simplify it as 9. Let's look at a more general case. Let's hope I give myself just a piece of, yeah, cool. Yeah, I did it the right way. Oh, I wouldn't turn to label. One of these days, I might actually ever remember to label my pages. We'll see. So page 3 up here. Cool. It's just labeled them ahead of time. All right, so we're going to do the same thing, except now we're going to make it very general. We're going to say we want to find or write the equation of a circle whose center isn't a specific point. We're going to call it h comma k, because that's, I don't know who picked those letters, but it's kind of the standard center. Those are supposed to represent numbers, so like h could be 1 and k could be 4, like in the previous example, or really whatever. And whose radius is given by lowercase r. Those are pretty standard choices for writing this general equation circle. Okay, let's draw a picture. It's not going to be very fancy. I'm going to pretend like my circle's over here. Wow, I didn't draw that very well. That's okay. Here's my center at h comma k. Here's any point on the circle. We usually call it x comma y. X comma y could be there. It could be over here. It could be down here. But the point is that this distance between x, y, and hk is r. Or this distance here is r. Or this distance here is r. And so now we use that knowledge to write the equation of the circle, because we're just going to use the distance formula again. We know that the distance between any of the points on the circle, x comma y, and the center, h comma k, is r. Or in other words, if we use the distance formula, that's going to be the square root of the difference in the x's. And not that you have to subtract it a specific way, but we usually like to do the variable x minus the actual point h, which we had a value for last time. So I'm going to write this as the difference in the x's squared. So x minus h quantity squared plus the difference in the y squared, y minus k quantity squared, equal to the distance, which is the radius, right? The radius is the distance from the center to the point on the circle. That is literally how a circle is defined. Okay, so then just like before, we square both sides. Squaring both sides, I'm going to get, now I think it's worth knowing that if you square both sides, you're just going to get rid of the square root, but I'm going to write it out just so everyone can see it. So we square both sides. So I guess I could have done up there, but I didn't. So I'm going to square this side, square this side. The square root of some stuff squared is just the inside stuff. So I'm going to get x minus h squared plus y minus k squared equal to the radius squared. And that's really it. This is the standard. Let me actually box that up there. It's the standard equation of a circle with center h comma k and radius r. One thing I'll point out is you don't have to derive this every time. Right? I'm deriving it to kind of show you how it works, but really we don't want to be doing this every time. We want to be able to be like, oh yeah, I kind of know the pieces to make this work. So let's do a few examples where we're not going to drive it every time. We're just going to talk about how you get there. So let's start off with something, sure. So let's say, oh, this is page 4. So we want to find the standard equation, and I am emphasizing the standard because there are other ways of writing the equation of the circle, which we'll talk about in class G. Find the standard equation of the circle with the following center and radius. So here's our first example. Let's say I'll use letters. Here's example A. So let's say the center is the point 0, 0, and the radius is 6. Okay. So all I'm going to do is I'm going to do x minus 0 squared plus y. All right. I'm just going to say it's going to be x minus the x coordinate squared plus y minus the y coordinate squared equal to the radius squared. So really, right, that 0 is going right there, that 0 is going right there, and that 6 is going right there. I should simplify this because x minus 0 is just x and y minus 0 is just y. So I should really just write this as x squared plus y squared equal to 6 squared, which is 36. So when you see something like this where you don't have a minus something, that means the center, the coordinate of either the x or the y is 0. I want to point out 0, 0 isn't a point on this circle. 0, 0 doesn't satisfy the equation. If I plug in 0 for x and 0 for y, 0 squared is 0, 0 squared is 0, and 0 plus 0 is 0, which isn't 36. And that's how it should be. The center is not a point on the circle. It's still an important point to be aware of, but it's not a point that's actually on the circle. Let's look at another example. We want to find the equation of the circle whose center is -3, 2, and the radius is 9. Same deal. I'm going to do x minus the x coordinate, and then I'm going to square that. Plus, don't forget the plus is necessary here. Y minus the y coordinate squared equal to the radius squared. The only simplifying we want to do here is we don't really want to write minus 3. I really would prefer to write this as x plus 3 squared plus y minus 2 squared equal to 9 squared is 81. It's not the square root of 9, which is 3. It's 9 squared, which is 9 times 9, which is 81. I will mention here, one thing I always think about when I'm doing this is if I plug in the center, if I plug in this value for x and this value for y, -3 plus 3 should be 0. 2 minus 2 should be 0. So if you actually plug in the center, the left side of this equation should be 0 plus 0 every time. No exceptions. Let's do maybe 2 more examples. Sure. Yeah, I'll use a different color here. Let's say our center now is the point 0, -7, and the radius is the square root of 13. Same deal. I'm going to write x minus 0 quantity squared plus y minus -7 quantity squared equal to the square root of 13 quantity squared. X minus 0 is just x. I'm going to rewrite that as x squared. Y minus -7 is y plus 7 squared. And the square root of 13 squared is just 13. It's literally how the square root is defined. It's the number that if you multiply it by itself, you get back the inside number. So the square root of 13 times square root of 13 is going to equal 13. So this equation is the equation of a circle, and the center is 0, -7. If you plug in 0 here and -7 here, you get 0 plus 0. And well, the radius was square root of 13. Cool. So I think that's not too terrible. Let's go the other direction. Let's start with the equation and then find the center and radius and also graph it. Let me grab some graph paper for that, which I think I have here. Nope, I do not. I have it over here. Cool. Oh, over here. Right on. Prepared. I know what I'm doing. Okay, so. And I'm just going to phrase it this way. So I'm going to phrase the question as, this is page 5, I believe, yeah. Graph the circle given by the equation x minus 2 squared plus y minus 1 squared equal to 4. Cool. So really, there's not too much to do here. First, but really to graph a circle, you have to be able to identify what the center is and what the radius is. So the center, I always think about it as the x and y value I can plug in so I get 0 on the left-hand side. So I have x minus 2, I need x to be positive 2. I have y minus 1, I need y to be positive 1. If I plugged in 2, 2 minus 2 is 0. If I plugged in 1, 1 minus 1 is 0. The radius, well, this side here is supposed to be the radius squared. So the radius squared is equal to 4, which means the radius is the square root of 4, which is 2. Okay, so I have all the things I need. I have the center, 2, 1. I have the radius, value of 2. I do expect if I ask you to graph a circle that you find those things and you state them somewhere. So then my center is 2 to the right, 1 up. And my radius is 2, which means I'm going to go 2 in each of the 4 cardinal directions, or north, south, east, west, or up, down, left, right. So 2 to the right, 2 up, 2 left, which exactly lands me on the y-axis. If your radius is equal to one of those coordinates, like your radius is 2 and your center is at 2 or -2 on one of the coordinates, you're exactly going to be that far away from one of your axes. And then 2 down. So there's my circle. And do your best to draw it. It will not always be perfect. It will almost never be perfect, but sometimes it'll look all right. That's pretty all right. As long as it's clear what your points are, I don't think you need to do any further labeling. You can label the center if you want. You can label these other 4 points. I've gone 2 to the right, so I'm adding 2 to the x coordinate. 2 up means I'm adding 2 to the y coordinate. 2 left means I'm subtracting 2 from the x coordinate. And 2 down means I'm subtracting 2 from the y coordinate. But you do not need to label those points. I just like labeling them so you can see what I'm doing clearly. Let's do a couple more examples. Let's say I want to graph, which really means find the center and radius, but graph the circle given by, let's do x plus 3 squared plus y squared equal to, sure, let's go 16. Okay, so first and foremost, the center. Center is going to be, so I didn't write it this way, but this is technically x minus -3. If you want to think of it that way, you can think of the x coordinate being -3. Personally, the way I think of it is, what do I have to plug in for x to make this part 0? Oh, -3, because -3 plus 3 is 0. This one always seems to throw people off for some reason. What value does y need to be? Well, I don't have y minus anything, or really I have y minus 0. So since that's really y minus 0 squared, the y coordinate is 0. Basically, you have y squared by itself or x squared by itself. The coordinate for that x or y is just 0. You can also think if I plug in -3 here, -3 plus 3 is 0. 0 squared is 0. If I plug in 0 here, 0 squared is 0 times 0, which is 0. The radius, well, I don't think you need to go through this. Like, I would just jump to saying the radius is the square root of that right-hand number, as long as it's written in this standard form. The reason I say that is because we're going to write it in a different form tomorrow, and you have to do more work to find the radius than just square root whatever's on the right hand side. Here, the square root of 16 is 4. So great, I'm going to go over to -3, 0, which is right there. There's my center. And I'm going to go 4 in each of the directions. So up 4, left 4, down 4, 1, 2, 3, 4 to the right. And then try your best to draw it. One thing I'll say about drawing circles, which is kind of atypical, most of the time when someone asks you to graph a thing, they ask you to find all the X and Y intercepts. It's just pretty standard operating procedure. But for circles, we usually don't. Oops, that's okay. So right here, right here, right here, and right here, I have X intercepts and Y intercepts. I'm not going to label them. I might label these X intercepts because they happen to be exactly to the right and to the left of the center. But I would, if I was going to label things, right, this is the point -3, 0. This is the point +1, 0. Here's -3 up 4. 4 left is -7, 0. 4 down is -3, -4. Cool. Yeah, that's it. Let's do a couple more because there's a few other things I want you to see. Yeah. So let's say I want to, sure, yeah. Graph the, let's label the pages. Page 7. The same thing. I'm just going to give the equation. So graph the following. Graph, let's say we have, let's make it interesting here. X minus, let's do it that way, yeah. X minus, sure, let's do X minus. X minus 2 squared plus Y plus 3 squared equal 2. Let's go 6. Yeah, 6 is annoying. So center is X is +2, Y is -3. Again, 2 minus 2 is 0, -3 plus 3 is 0. The radius is not ideal. The radius is the square root of 6. So fine. What do we do? Well, let's plot the center first. So over 2, down 3. Here's my center. Now the square root of 6. This is where you kind of need to know what numbers are between. Square root of 6 is between. So I'm going to point out that 1 squared is 1, 2 squared is 4, 3 squared is 9. So I think the square root of 6 is between 2 and 4 because the square root of 4 is 2. That's less than the square root of 6. And that's less than the square root of 9, which is 3. I don't need to use a calculator. I certainly could use a calculator here, but all I really want to know is 6 is between 2 and 3. I don't actually know what it is. It's approximately 2 point something. But what that means for me is I'm going to go in each of the 4 directions 2 and a little bit more. It does not need to be super precise. Yeah. So I'm going to go 1, 2, and I don't know if 6 is like bigger than 2.5 or smaller than 2, or sorry, the square root of 6 is bigger than 2.5 or smaller. I guess I could use a calculator. I'm not going to. I'm just going to say, it's about 2.5. No one needs to be perfect here. Up 1, 2, and a bit more. Left 1, 2, and a bit more. Down 1, 2, and a bit more. Is it perfect? No. Is it good enough? Yes. Is my circle perfect? Probably not. Ooh. Okay, we can do it. Oh, wow, that's terrible. I mean, it's fine, but like it doesn't look the best. Again, no need to label these points if you don't want to. But if you were going to label them, this would be 2, -3. This point over here, where I've gone the radius, which is root 6 to the right, would be 2 plus root 6, comma -3. This point here would be 2, comma -3 plus root 6. This point here would be 2 minus root 6, comma -3. This point here would be 2, comma -3 minus root 6. Interesting. We need to do, let's do one more, and then we will do one more thing after that. One more, let's say. So yeah, let's say one more time, let's find the equation, or sorry, let's graph the circle given by the equation x plus, x plus 4 squared plus y plus 5 squared equal to 1. Oh, sorry, I can't quite see that. There we go. This one I made a little easier. It's fine. So my center is going to be x is -4, y is -5. My radius is the square root of 1, which is just 1. Okay. So I go left 4, 1, 2, 3, 4, down 5, 1, 2, 3, 4, 5. Right there's my center. And then I'm going to go 1 in each direction. So it's not going to look very exciting because my radius is pretty small. Go 1 there, 1 there, 1 there. That's not a 1 right there. It's just a straight mark that I just happen to draw. I can zoom in. Let's zoom in a little bit. Ooh, extreme close up. Okay. So then we've got this, and I'm just going to draw my circle. So it looks like that. That's pretty good. That's not the best, but it's all right. So right there's my center at -4, -5. And all these other points, right? This point is 1 to the right, so -3, -5. This point's 1 up, so -4, -4. This point's 1 to the left, so -5, -5. This point's 1 down, so -4, -6. All the points that are up and down should have the same x coordinate. All the points that are left and right should have the same y coordinate. All right, one more kind of thing that is common to do with circles is to ask the, let's get that center. Okay, there we go. Is to ask the following kind of question. And I think I just want regular paper here. I don't need graph paper. So here is the setup. This is 9. Yeah, 9. So I'm going to draw a picture. So here's the setup. I wanted to use the word sorry. That's an A. A diameter of our circle has endpoints. And we'll do the first one. We'll make the first one nice. Sure. Yeah, we'll do the next one, the first one. -2, -3, and 4, 5. So first of all, what does it mean that the diameter, well, what is it even is a diameter of a circle? The diameter is a segment that goes from one side of the circle to the other, and it happens to pass through the center. Other points that do that are called, I think they're called chords, but a diameter goes from one end of the circle to the other and passes through the center. So let's say the center is like right there. So here is a diameter. There's my center. There's my endpoints. So what they're telling us with this information is my circle goes to the points, or hey, so the diameter has endpoints -2, -3, and +4, 5. And what I'm at, and you don't have to draw this picture to do this, but what I'm doing. And then I want to know what is the equation of the circle. Which is really just a roundabout way of asking you what's the center and what's the radius. So to find the center, I'm going to use the midpoint formula because the center of this circle is the midpoint of these two endpoints of the diameter. So I need to find the center, which is going to be the midpoint of -2, -3, and 4, 5, which is going to be -2 plus 4 over 2, -3 plus 5 over 2, which I think is going to be, let's see, -2 plus 4 is 2, 2 divided by 2 is 1, and -3 plus 5 is 2, and 2 divided by 2 is 1 again. So not very exciting that they're the same. Oh well, sometimes happens. And the other thing we have to do is find the radius. So there's a couple ways you can go about finding the radius. My preferred way is to use the center you found and then find the distance between this point and that point, or this point and that point. Either way will work. Let's do it. Let's do it both ways, actually. So find the distance between 1, 1 and -2, -3, which is probably not what I would choose. Well, it's going to be, sorry, I should write the word distance. Distance between, let's see, I'm going to get square root of 1 minus -2 squared plus 1 minus -3 squared, which is going to be square root. Let's see, 1 plus 2 is 3. 1 plus 3 is 4. 3 squared is 9. 4 squared is 16. We've seen this before. 9 plus 16 is 25. This is going to be 5. Or if you use the other point, you should get the same result. If we use 1, 1, and 4, 5, the distance is going to be, let's see, the square root of 4 minus 1 squared plus 5 minus 1 squared, which is the square root of 3 squared plus 4 squared, which leads us back to 5 again. Or if you prefer, this is not my preference, but you can find the distance between the two endpoints. So you can say, I'm going to find the distance between these 2 points. That'll be the diameter length, and then cut it in half. So if we do that, let's just do that just to see it. So we do that, we say, well, if I go from -2, -3 to 4, 5, using the distance formula, it's going to be the square root of, let's see, 4 minus -2 squared plus 5 minus -3 squared. And that's going to be, let's see, 4 minus -2 is 4 plus 2, which is 6, and 6 squared is 36. And 5 plus 3 is 8, and 8 squared is 64. And 36 plus 64 is 100, and the square root of 100 is 10. And then 10 divided by 2 is 5. So any way you slice it, the radius of the circle is 5. So then I'm going to write the equation, and the equation is going to be x minus 1 squared plus y minus 1 squared equals 5 squared, which I should just write as 25. If you want to take an extra step, that's totally fine, but your end result should be the right-hand side written as just a nice number, not as some quantity squared. Cool. Let's do one more example like this, and then that'll be it. One more example where the radius isn't quite so nice. So page 10. So same deal. We have a circle whose diameter has endpoints. What have I got here? Let's see, 2, 5, and 8, -1. Find the equation. And to find the equation of a circle, we really absolutely have to know the center and the radius. So again, the center, just like last time, is we're just going to find the midpoint of these two endpoints of the diameter. So the center, I'm just going to find the midpoint. So we're going to do 2 plus 8, right? The average of the x's divided by 2. And the average of the y's, 5 plus -1 divided by 2. Right, that's our midpoint formula. So that's going to be, let's see, 2 plus 8 is 10. 10 divided by 2 is 5. 5 plus -1 is 5 minus 1, which is 4. 4 divided by 2 is 2. So there's your center. And you can find the radius. I'm going to do it. I'll show 2 of the ways. So one way to do it is going to be the distance between your center and either one of these 2 points. I'm going to pick this point just because I feel like this point could be confusing since the coordinates are kind of feel like they're the same. So let's do this point instead. So the distance is going to be, let's see, the square root. Sorry, this is the square root of, let's do these ones. 5 minus 8 squared plus 2 minus -1 squared. Which ends up being the square root of, let's see, 5 minus 8 is -3 squared. 2 plus 1 is also 3. Well, not also, it's just 3 squared. So that's going to be the square root of -3 squared is 9. 3 squared is 9. 9 plus 9 is 18. Okay, that's one option. Or the other option is to find the length of the diameter. So this is the radius length. Diameter length would be distance between these 2 points. So square root of, let's do 8 minus 2 squared plus -1 minus 5 squared. That ends up being the square root of 6 squared plus -6 squared, which is the square root of 36 plus 36, which is the square root of 72. And you can just divide that by 2, or some simplifying first. So here we'd say our radius is square root of 72 divided by 2, which does simplify to the square root of 18. It's just not something we've really talked about how you do that. And then we can write so we're not done, right? We found the center, we found the radius, now we have to write the equation. So the equation using, and I'll do it both ways. Using the radius I found here, the equation is going to be x minus the x coordinate of the center squared plus y minus the y coordinate of the center. I wish I had made one of those negative, but I didn't. Oh well, today in the past problem. I didn't in another problem. That's an oversight. I should have made one of them negative. And then that's going to equal the radius squared, so the square root of 18 squared. And simplifying, I get x minus 5 squared plus y minus 2 squared equal to 18, because the square root of 18 squared is 18. Or if I'd done it using this, I could have said it's x minus 5 squared plus y minus 2 squared, right? The center doesn't change, equals the square root of 72 divided by 2 squared. If I square that, I get x minus 5 squared plus y minus 2 squared. The square root of 72 squared is 72. 2 squared is 4. 72 divided by 4. I'm divided by 4, I'm never good at, but I can divide by 2 twice. 72 divided by 2 is 36. 36 divided by 2 is 18. So 72 divided by 4 is 18. And I definitely get exactly the same. So either, this is the way we should write our final answer. But if you don't want to, I would recommend always finding the radius is just the distance from the center you have found to one of the points you were given. But some people like to do it this other way because they just do. All right, that's all I've got. I will see you in class. Talk about some circles. Bye.